Hi, this is Shuayu Liang again, doing the probability and the statistic homework first, and I goes to the question second. The question is like given two probabilities and to prove that the two conditional probability add with each other equals to 1 if and only if A, B are independent. So this question actually needs us to prove in two steps. One is that given the A, B are independent, how we prove the two are added with each other equals to 1, and another is then given these two conditional probability added with each other equals to 1 and prove that A, B are independent. So first things first, I'm seeing that one of the condition or the things we might use is a conditional probability, and I'm gonna still using the definition of that to write as this part. So the probability of the probability of A under the condition B and the probability of not A under the condition of not B goes like this. So the first, if we're given a condition of A, B are independent, that is A probability of A times probability of B equals to the probability of A and B. So if we want to prove this, we better write this part more specifically and this part more specifically. So the two part goes like this. If we write them not A and not B as 1 minus A and 1 minus B, still the same with the denominator. So given a condition like this, so we could write the probability of A and B like probability of A times probability of B, and to divide it by probability of B. So the next part of probability of 1 minus A times 1 minus B, we could write as 1 minus A minus B and plus A and B. So this part goes to 1 minus probability of A, probability of B, minus probability of A and B. And the denominator is the same, like probability of 1 minus probability of B. So still we can do in the following steps that this B and B go divided by each other. So we write it as the same fraction that the denominator is 1 minus the probability of B, and the numerator goes to like the probability of A, and it's all the calculating things. I'm sure that I would done quite right in this part. So everybody just do the calculation in this part. So it's not and to use the condition here as a probability A and probability B, they multiply each other. So after these steps, we could find that it actually goes to like the denominator and the numerator goes like all the same if 1 minus the probability of a B, and that end up being the 1, and that the first step of this question just proved. So it goes on to the next step of this question, that is given the two conditional probability added with each other equals to 1, and to prove that A, B are independent. So the things we're going to prove is still that the probability of A times probability of B is equals to probability of A and B. So given these condition, we have the same, like we write the same thing, but this time we're not gonna divide the probability of A and B. Just do the same thing as write it as one factor, and this time we could see that the actually probability of A and B times probability of B, we could have the plus probability of B times probability of A and B. So this two part goes divided, just gone, and it's still the same that we goes here. It's all about the calculation again, and the probability of A and B added with the probability of B minus probability of A and B, probability of A times probability of B equals to the probability of B, which is alright. We could see that then we could see that the probability of A and times probability of B is equals to probability of A and B. So I guess two parts of this question are proved. So we could say that probability of A on the condition of a B plus probability of not A on the condition of not B equals to 1 if and only if A and B are independent.